Welcome to today's webinar. The topic today is Introduction to RFEM 6 and RSTAB 9. Today is part 1, modeling and load input of this structure here on the right side. My name is Andreas Hörold. I'm responsible for marketing and public relations in the company Dlubal Software. I'm responsible, for instance, for the Dlubal website, the German and English webinars, customer projects, and so on. I will be the moderator today and also the presenter, and I will be supported by two colleagues, and my two colleagues can introduce themselves.
Hello, my name is Oliver Metzkes, and here at Dlubal I'm working as a customer support and product engineer, mainly responsible for steel design.
Hello, my name is Sandy Matula. I'm responsible for the customer support. Today I will answer your questions.
Okay, thank you for your introduction. Then we can switch off our webcams that the attendees can see the full screen. I say something about the questions, how you can ask questions via the control panel on the right side of your screen. You can show the panel with that arrow here, and then you can enter the question here, and my two colleagues will answer you. If you don't get an answer during the webinar, because there are too many, you will get an email afterwards. The other way is to watch the entire webinar and then email questions to info@dlubal.com. To the agenda today, at first I will give general information about the graphical user interface of RFEM 6. Then I model a steel timber structure. You can see the structure on the right side. And then I will enter loads, and I will also use the load generation wizards in our program. Okay, then we turn to the program RFEM 6. I start left above, File, New. You can also use the button, this button here on the left side above. Then the first dialog, the base data is opened. I enter a model name. I call it shelter or roof. Doesn't matter. It's a 3D model. New in RFEM 6 is the 2D model and the consideration of 3D internal forces. It's better to explain with the 1D model. For example, where are a 1D beam, and you can consider My or VZ. And with this new option, you can consider also torsional moment and MZ. Okay, that's for the users that already maybe know RFEM 5 and know they are interested in RFEM 6. That's why I interrupt the presentation, because I have a question to you. So I start with the question: which structure analysis software do you use? Just click on the answer that is valid for you. RFEM 5, the old program generation, RFEM 6 or RSTAB 9, the new program generation, or other software. I wait a short moment. It's anonymous and nobody will see your answer from the other attendees. Just click on the right answer that's valid for you. I still wait 3 seconds and then I will close the poll. Okay, I close the poll and show the results. The most of you use the old program generation or use other software. Yeah, and almost half of you use already RFEM6 and RSTAB 9. I suppose you are new users, or you use RFEM6 or RSTAB 9 not so often. That's why you use or you want to see the introduction webinar. Okay, quite good information to me, and I will disable the poll. Okay, then we continue with the presentation. That's a dialogue that the RFEM5 users already know, but within our design, you can choose the project with that drop-down menu, and where is it Dlubal Center, where you can organize your projects. Later I will open the Dlubal Center. The initialization of the new model can be blank, or you can use an existing model as copy, or a template, or a block. I will show the blocks later. Okay, 3D. We use only members in this webinar, but the surfaces and solids can be selected as well. That's no problem. Then I open the next dialog, add-ons. Where are all add-ons that you purchased? They are in green. The gray add-ons are still under development, and they will released in the future. I check on the combination wizard and classification. The load combinations should be generated automatically, and I will use the load wizards. For example, the snow load wizard. And I use the steel and timber design add-ons. The design follows in the next webinar on next week, but I already check the add-ons on. Then I have to select the standards. There are a lot of international standards, for example, for the load case classification are available. I use the Eurocode 0, base, and timber, because the construction contains also parts from timber. So the national annex, a lot of annexes of the Eurocode are available. I use the German national annex. Then the load wizards, according to Eurocode 1, also a very lot of international standards are available. I use the Eurocode 1 and the German national annex. And those standards are already available in the main program. There's no add-on necessary for these standards. For the steel design, is this steel design add-on necessary, but it contains all these international standards. You don't have to purchase the standards separately, all are included. I select the Eurocode 3 and also here the German national index. So then timber design, all these international standards are available in the timber design add-on, and I select the Eurocode 5 and the German national annex as well. Standards 2, there's only the steel joints add-on that you can select if you want to design steel joints, but not in our webinar. Then settings and options, where are general settings. For example, if the set axis should be downward or upward, I leave it downward. But I select the member representatives and the member set representatives. Those are new functions in RFEM 6 and RSTAB 9, but we come to that point in the second part of the webinar. That's for necessary for the design. Imagine we have got 6 columns, but we will design only one member representative, means only one column. Or in our case, we have got 3 columns with the same length, and that's why we have got one member representative for these 3 columns. But we will come to that later in the second part of the webinar. So that's all the options for the member representatives. We want to use them for the steel design and the timber design. The same for the member set representatives. So then we select the dialog member model parameters. You can see here the member model parameters. You can enter any text here. You can load the location of your construction to use it for the different load wizards, snow load wizard and wind load wizards. I will do that later in the program. So then dependent model, it's not interesting today. And also the terrain, you can define different terrains. Then the history, it's empty at the moment because it's a new model. Okay, I can leave the dialog with OK. And a new space for the modeling is available now. So for these users that are already use RFEM 5, you can see it's nearly the same interface. It's modern, some new functions. But if you want to create a node here on the left side, or a line, or a member, or a nodal support, that's the same workflow as in RFEM 5. But what is new? That's the Dlubal Center. I opened the Dlubal Center. That is the project manager. Now you can see that's the current project. That's our empty model shelter. I already tested it. That's the finished model, and those are the models from the German webinar that I presented last Tuesday. Okay, those are models from previous webinars. Or where are the examples? For example, construction stages, dynamic analysis. You can see a 3D model on the right side here. Then the model information, number of results, if you have got results, number of nodes, number of lines, and so on. So, okay, then we can turn to my account. Then the Dlubal extranet is opened with the extranet messages, your data, the company data, the licenses, products to download, and the new program generation, and also the old program generation. And what's quite interesting to you is the development page here, where are implemented features. For example, you can select for timber design, or can display all, or concrete design, for example. You can submit a feature request. That's quite important to us, that you enter wishes here, that we can make the best static analysis program ever for you, that you can use all the features that you want. Okay, I leave the extranet. I turn to the templates. I've got no templates, but you can save templates for your projects here. This is quite new. The blocks, those are, I've got also parameters, or the most of them have got parameters. You can select trusses, 2D, 3D, or frames, tapered frames. What also, for example, stairway structure, steel and concrete, and so on. Let's click on one truss, and you can see that the truss is parameterized. You can enter the values here, for example, 20 meters, 3 meters high, and you can select another section and so on. And you can import it in RFEM 6 or RSTAB 9 if you want. Just use such parameterized blocks that you don't need to start at the beginning of such a model. Okay, that should be all the main information of RFEM 6 and RSTAB 9. Just try it if you don't already use RFEM 6, for example, with the trial version that is free for 90 days. Okay, then we start. On the right side above, I select another work plane, XZ, and I change the view in -y direction. And I start with the first column. Left above, here, new single member. I only have to change a new section. Okay, that's already the section that's from the test that I want to use, but I show how you can find it. You can go here above in the library, and there are the standardized cross sections, thin walled cross section, massive, and so on. So I select the square and rectangular hollow sections, and I select the square hollow section, and 100 by 100 by 6.3. And at the bottom on the right side, I can choose a material. I open the library. There are a lot of steels available. You can choose the different region, material type, and so on, and then select your material. That's quite easy. Okay, so then all entries for the first member are done. I apply all and create the first column, 3 meters high. Okay, then left above, I assign a nodal support where are predefined nodal supports, and I select the fixed nodal support. I press the Edit Nodal Support button, and this dialog has opened, and you can see that where also non-linearities are available, for example, failure if a positive px, or a friction diagram, and so on, that you can define in the different directions for the support, or around a different or a certain axis. Yeah, failure diagram, stiffness diagram, and so on. So I apply that and select this node. So what's new in RFEM 6, you can click on it or select it and then right click, and you can decrease or increase the size of the support. It's also possible for loads, etc. Okay. So then via drag and drop, I select the column, and then I press the Control key, and you see on the mouse, you can see the plus sign. That means that I copy the column, and if I don't press the Control key, there's nothing that. And if I do that, I only move the column. So, but I press the Control key and copy it 5 meters in X direction. So then let's create the horizontal beam. I create a new single member, left above, section, new section. Okay, that's already the right section, but I added it that you can see how you can find it in the library. Also a standardized cross section, an I-beam or H-beam, HERA 160. Okay. So then the cantilever, this part. So, and I copy that part here, but you can see I select only this horizontal beam and this column, and also this column is selected because you can see that points, and those are the member representatives. But as I said, we will use that in the second part of the webinar. That's why I go here left at the bottom, and I open the display navigator and deselect the member representatives and the member set representatives. So, and I select the horizontal beam and the column again. And this time we don't use the drag and drop function, but the move and copy function, right above, move copy selected objects. So I create a copy, and I copy the structure 5 meters in X direction. Okay. I only add the cantilever here with a new single member, section HE 160A. Okay. Okay. So now we have got 4 different horizontal beams, but later we want to design one member. That's a continuous member in the reality. That's why I select all the members. It's also a function that already was available in RFEM 5. I do a right click, then members, and I create a member set. Okay, all these members are on the right side, on the top. You can see that these members are included. Okay, and you can see on the pointed line here that that is the member set. Okay, so then I copy the steel structure 4 meters in Y direction. I select all. Then on the right side, on the top, the move and copy function, I create a copy and copy it 4 meters in Y direction. Okay. So the steel construction is finished. We continue with the timber members. So left both, new single member, section. Now we've got 2 sections. I create a new section with the import button from, as I imported from the section library, a massive rectangular cross section. So that's the cross section. I go in the next dialog and I enter the parameters. 60 millimeters as the width and the height should be 160 millimeters. Okay, go back to the main dialog and you can see the material is not correct. I select the timber material. Now that's already the right material. I go to the edit button and the library. Now you can select or you can choose the different filters: European Union, material type, timber, material subtype, solid timber, and then the softwood C24. Okay. That's the correct cross section. So I create the first member. Oh, where's a rotation? Okay, that was my mistake. I undo that here above. So I have to change the work plane. I'm in the work plane XZ. I change it to YZ. Yeah, now you can see that's the right work plane. Yeah, but you can see if you make a mistake, you can undo that. You can also undo more than one step. Can go directly to a previous step. All is possible. So, okay, again, the timber member. Okay, all is correct. So, three members. Okay. It's in the same height or the same axis as the steel structure. In reality, the timber member will lie over the steel construction. Now, if you want to consider, for example, additional moments because of an eccentricity, then you can create an eccentricity. In the case of this structure, in my eyes, that's not necessary, but I would like to show how you can create it, but later. Or we can do that immediately. So I select all with the control key. You can see the plus. So then a right click on one of the members, member, and then edit. So, and then I can select an eccentricity, go to the table eccentricity and create a new eccentricity. Yeah, the relative to section eccentricity is available. The RFEM5 users know that already. I think the bottom of the member, of the timber member, should be on the top of the steel member. I select the steel member. Okay. The same at the end. Okay. And now if you change the view to X direction, the eccentricity is correct. But I won't use that in this case here, in this webinar. So let's calculate the self-weight load case that's automatically created. You can see all is rigid here in that nodes, the timber members and the column, for example, and you will have not a continuous moment picture. Yeah. So let's take a look at the internal forces. On the left side, you can see the navigator results, MY. And I would like to display only the timber structure. How can you do that? On the left side, on the bottom, you can see the views. And you can open the navigator views. And then you can activate visibilities, for example, for members by materials, and you can select only the timber members. Yeah, and you can see there's a difference for the moment in this node. And that's not correct. How can you solve that? With a scissor hinge. So I create a scissor hinge. I select the member. I select hinges for the member, and I go in the dialog hinges. So with that button here, I create a new hinge on the member start. So, and I have to change the coordinate system global. I can create scissor hinges only for in the global coordinate system. So I select the scissor hinge. You can see the axis here. The green axis is Y, the red axis is X, and the blue axis is Z. And the scissor hinge should be free around the X and Z axis. Okay. The same scissor hinge at the end. I mean, only at the end, not at the start in that case. Okay. I have to uncheck the ignore related objects that I can see the scissor hinge. Then I select the middle member and select the hinges and choose the scissor hinge on both ends. Okay, and at the beginning of this member. So let's calculate all again. So, and that's good. There's no difference in this node for the moment. Okay, yeah, that's why the timber member is continuous over the steel construction. On the top here, right, you can cancel the visibility mode. You can do that, or you can go to the navigator data navigator views on the left side, on the bottom, and can deactivate it. Okay. So the next step is to copy all the timber members. I selected with the control key. Now you can see the plus. I select all 3 members. And then on the top right side, the move and copy function, create copy 11 times and 1 meter in X direction. Okay. All results are deleted. That's okay. And I have to copy the member in -X direction 1 times. Same function, create copy 1 times and -1 meter. Okay. The construction or the model is almost finished, but if we change to the X view, you can see there's no roof pitch. You could change the nodes, the height of the node or the set coordinate of the nodes with the trigonometric functions. You could calculate it, but it's quite easy on RFEM6 and RSTAB 9. You can select all the members, then do a right click and go to manipulation in the context menu and then chamfer. So you can enter a rotation angle in degrees or in percent. If I enter the degree value, the percent value is calculated automatically. Global coordinate system. I select a rotation axis and a direction. We want to do the chamfer through the axis X. That's the axis what we look at the moment, and in direction Z. So, and I have to select the rotation point. Okay. And apply R. And now we've got a roof pitch. So that's the completed structure. Later I will apply the loads, for example, also the wind load. And according to the standard, for example, when I have a wind in Y direction, I have to load the half of the roof. That's why I create a so-called help node in the middle of that member and that member. I do a right click and open the context menu, member or members, and I divide the member in n intermediate nodes. 1 node, and that's a new function in RFEM6. I can create a on member node without dividing the member. Okay. Now you can see the nodes, but the member isn't divided. Okay. Now the whole model is finished and we can continue with the loads. As I said, the self-weight load case is already created. We can press that button here, edit active load case. And the main dialog, load case and combinations has opened. Those are the base data that we are defined at the beginning. we selected the base and timber standard group and the German national annex. I did forget to select something in the base data dialog, but I can do that here as well. I added the parameters of the national annex, and I select another deformation coefficient, KDEF, 0.8, because we've got service class 2. Okay. We will also use the combination wizard, but we will come back to that later in the second part of the webinar. So load cases. Load case 1, self-weight. The action category is permanent. That's okay. And the self-weight of the structure is already activated. So then I turn to the function or the feature insert. Left on the top, insert load wizards, and you can see there are a lot of 5 load wizards are available. Member loads from area load wizard, then the member loads from free line load wizard. You can transfer the support reactions from one model to another model. You can choose the snow load and wind load wizard. We will use the first load wizard and the snow load wizard later. Okay, I start with this load wizard. Self-weight. The load distribution should be uniform. The global coordinate system, the load direction should be set. That's correct. You can see it in the display. That's the right load for self-weight. So the load magnitude should be 25 kilogram per square meter. For example, a formwork or a plate of timber and a foil over the plate or the formwork. That can have a weight of 25 kilogram per square meter. I have to select the geometry. So, and with this button, I have to select the corner nodes. So I select the 4 nodes and the start node. Okay. And this function is also already available in RFEM 5. I can exclude members from the load, and I select members parallel to straight members number, this member, the steel member. Okay. Okay. So that's the load, and I can right click on it and display the load separately. And you can see the load is, or the line load is correct. 0.25 kilonewton per meter and a half on the edge beam. So I can display it not separately. I open the context menu again, and you can see that I can increase or decrease the display of the load in the context menu. So then we create a new load case, with this button here, new load case. And the new load case is snow. I have to change the action category. You can see there are, for example, imposed loads, the wind load, snow load, temperature, and so on. We select the snow loads with a height under 1,000 meters. Okay. Then I select I insert the next load. Insert. I use the load wizard, snow load wizard. So you can select the roof type, dual pitch or flat monopitch. We have monopitch roof. I select the 4 nodes. Okay. I exclude again members from the load. Now with that button here, select parallel objects and graphic. Also the steel member. Okay. So, and then we turn to the next dialog, the parameters. You can define the snow load with the map and parameters or user defined. You can select the load zone, the altitude, the characteristic snow load. In this webinar, we would like to use a map. Left on the bottom, you can see the import button here, import location. I select it or I press it. And then this map is opened. Maybe you know that from our website. Now it's connected with our website. And you can enter the location here. I entered the Grimmarsche Straße 13 in Leipzig. That's our subsidiary in Leipzig. It wasn't found. That's strange. Just a moment. Maybe I haven't got a good internet connection or a connection to our website. Okay, it doesn't matter. I search it in the map. I select a location in Leipzig and you can see the snow load zone and the characteristic value of the snow load. The height is also quite okay, and I can press OK. And all the parameters are transferred in the program. Load zone 2 and the characteristic snow load of 0.85 kilonewton per square meter. One load case is available. We created it previously, so now I press OK, and the load is visible. I can increase it a little bit and can display it separately. And you can see it's quite okay. The steel members don't get any load. So then we can create the next load case, the wind load case. I do that another way. I open the navigator data, left on the bottom. You can see the button here. You can see the load cases, the load case and combinations. You can open that with a right click, or you can right click on the load cases and can press new load case. A different possibility to reach the dialog. Often in RFEM6 and RSTAB 9, you've got more than one possibility to reach a dialog. So I call it wind. Why? Pressure. I have to select the action category, wind. Okay. And I can leave the dialog. Yeah, according to the standard, where are for the wind in Y direction is we have to consider a load in the quarter of the roof in the direction plus Z, downwards, and a load upwards in the quarter. I think that single load should be on the half side of the roof. So that's why on the left side above, I insert a load with the load wizard, member loads from area. That's the wizard that we already used. I change the coordinate system to local, and the load direction should be perpendicular to the plane. And you can see set perpendicular to plane of the area. So, and the load magnitude should be 0.2 kilonewton per square meter. I have to select the geometry. As I already mentioned, the half of the roof. I distribute the single load from the standard to the half of the roof. I exclude the steel members again with that button here, members parallel to straight members number. Okay, I have to select the steel member and can press OK. We can display the load separately. That's okay. So then the wind load on the members, I select all the members, and then above here, new member load. Force, uniform. You can see the different possibilities, what is available in RFEM 6. Then the load direction should be Y. And the load magnitude 0.1 kilonewton per meter. Oh, that was wrong. 10 kilonewton per meter. Yeah, you can undo that, but you can search the load in the navigator data. You can see the loads here. Wind, pressure. Where are the member loads? Those are the loads from the load wizard, and you can click on the member load here. I selected 10 or entered 10, but it should be 0.1. Okay. That's a possibility to change a load if you have a mistake, as I did. But you can also select the loads with the control key and then double click on it, and then you can also enter the load. Okay, so one load is missing. In this example, I would like to define a wind stripe with a height of 1 meter, and I applied it on the steel member. That's why I go in the navigator views. On the bottom left side, I select the steel construction. So, and then I go to new member load on the top in Y direction, that's okay, and 0.55 kilonewton per meter. Okay, and I select the horizontal beams. Okay, so that's all for this wind load. I cancel the visibility mode. So then I go to the load case and combinations. I open it, the dialog, then load cases. I select the load case number 3 and left on the bottom, you can see the copies selected load cases feature. I press it, then I rename it from pressure to suction and leave the dialog. Okay, and I have to only double click on this surface load and need to change the value in minus 0.1 kilonewton per square meter. So, and that's the load case number 4. Load case number 3 and 4, according to the Eurocode. Only 2 load cases are missing: the wind in X direction pressure and wind in X direction suction. I create a new load case, this time with this with this button, on the left side, new load case. I call it wind X pressure. And then the same workflow. I go through a little bit quickly here. I insert load wizards. So load direction locus set 0.1. The geometry is this half of the roof. Okay, and I click the members that shouldn't get any load. Display separately, all is okay. So then the load on the columns, member load 0.1 in X direction. Okay. And I would like to apply a wind stripe of 1 meter high on this side here, but I want to apply it to the timber member because he would get bending around the weak axis, but I have a stiff plate over those purlins of timber. Yeah, that's why I apply the load as single loads. So new nodal load in X direction, a force. You can also apply loads and components and so on. Force in X 1.6 kilonewton. And this node and this node. Okay, that's all. We go to the load cases dialog and I copy that load case again. Rename it to suction. And I change only this load. This time minus 0.2 kilonewton per square meter. Okay, let me check all the wind load cases. This, okay. No, that's not correct. Sorry, load case number 4. Okay, that's not correct. It should be 0.1 3 kilonewton per square meters. So then 0.1. Okay, yeah, that's all. Let me display also the self-weight load case and the snow load case. All load cases and also all combinations are created because we checked the combination wizard, but the combinations are topic or one topic of the next webinar. That should be all for the modeling for this webinar. Let me turn back to the PowerPoint slide. If you want to get a free online appointment, for example, a free product demonstration, or you want to get a non-binding offer, then just contact our sales team with that link here, or you can scan the QR code. You can download the PowerPoint from our website. Also the recording. Let me show where you can find all. That's our website, dlubal.com. Then under news and events, you can find the webinars. That's the webinar of next week. If you want to see the second part, then just register if you don't have already done it. Then the week after next week, the most frequently asked questions webinar. And there are also our webinars available. That's today's webinar. I click on it. You will get an email with a link to that page when the recording is available. You will find the recording here in the middle. You can already find the presentation slides here. And you can also find the model. That's the model from the German webinar. It's the same model as for today. Okay. Then I thank you for your attention. Hope we meet each other next week or in a future webinar. Thank you to my two colleagues for answering the questions. Maybe one wish for to the attendees: when you leave the webinar, there's a small survey. You can enter wish for future webinars. You can score the webinar. It's quite important for our quality management. Just note that the worst score is 1 and the best score is 5. If you give stars, 1 star bad, 5 stars good. Okay, thanks again. Have a nice rest of the day and bye-bye.